Good morning, dear students. A warm welcome to all of you for our today's digital session for the subject Science and Technology Section A. In our previous session, we have completed with the explanation for chapter number 6 from Physics, Refraction of Light. We have even started with the discussion of textual exercise. So let us start with the discussion of textual exercise once again and let us proceed ahead. So our today's session will include discussion of textual exercise, additional questions related to the chapter and activities page wise, and the solved numerical examples. So I request all of you to be present with a textbook and a pencil in your hands. So we begin with the textual exercise. Question number 1 we have already completed yesterday. Let us go through it very quickly. Fill in the blanks and explain the completed sentences. Refractive index depends on the dash of light. This all we have discussed. So let us go through it very fast. It depends on the velocity of light. Explanation here which I had given was refractive index of the medium is inversely proportional to the velocity of light. As the refractive index of a medium increases, speed of light going through that medium decreases. As I have informed you right from the beginning, this is the explanation from my side. Any other explanation related to the concept, it should be logically and scientifically correct. You can write on your own. Next is the change in dash of light rays while going from one medium to another is called refraction. So change in direction of light rays. Here you can just give the definition of refraction of light on page number 73. Light changes its direction when going from one transparent medium to another transparent medium, which is called refraction of light. I have told you bending of the light rays when the medium is changed is called as refraction of light. Let us move to the next question, that is question number 2. A we will keep aside, towards the end of the video I will discuss. Question number 2b is about the formation of a rainbow. They have asked us, prove the statement. A rainbow is the combined effect of diffraction, dispersion and total internal reflection of light. I have given you the answer in marking on page number 78. The first point is, in your first point you should explain which phenomena are involved in the formation of rainbow. The beautiful natural phenomenon of the rainbow is a combination of different phenomena: dispersion, refraction and total internal reflection of light. See, here I have used a different color. Wherever I use different colors in the answer, you have to highlight in your answer sheet, that is mark it. I have told you in certain give reasons or proving of the statements, you have to mark the main part. Next, now I have given this answer in marking on page number 78 of your textbook, last paragraph, fourth line, fifth line is your second point. It can be seen mainly after a rainfall as small droplets of water act as small glass prisms. Continue marking. When light rays from the sun enter these droplets, it gets refracted and dispersed. That results in a spectrum. This part I had told you to add in your textbook. Finally, fourth point, then there is internal reflection inside the droplet, and after that once again the light gets refracted while coming out of the droplet, and as a collective effect of all these processes a beautiful rainbow is formed. And also I had informed you, when any question for 3 or more than that marks is asked on rainbow, you have to draw figure 6.10, that is the rainbow production from the textbook. Up till here we have completed in our previous session. Now let us start with our today's discussion. Question number 3. Mark the correct answer in the following questions. Nothing but MCQ. First question is, What is the reason for the twinkling of stars? Different options are given. Explosions occurring in stars from time to time, absorption of light in the Earth's atmosphere, motion of stars, and changing refractive index of the atmospheric gases. We have studied the concept of twinkling of stars. This twinkling, the stars appear to be twinkling because of the change in the refractive index of the atmosphere. So fourth option is your answer. Changing refractive index of the atmospheric gases. Second is, we can see the sun even when it is little below the horizon because of which phenomena? Reflection? No, it is due to refraction. So refraction is the correct option. Dispersion is also wrong, and absorption of light is also the wrong option. So see how the concepts which you have studied are there in the MCQs. Third one, if the refractive index of glass with respect to air is 3 upon 2, what is the refractive index of air with respect to glass? If glass with respect to air is 3 upon 2, then air with respect to glass will be just inverted value of the main value. So if it is 3 upon 2, answer will be 2 upon 3. Now question number 4 is numerical examples. Numerical examples and solved examples we will take together. So now I will just discuss the additional questions, because if you see the textual exercise, very less amount of theoretical questions are given. So n number of questions can be asked on this chapter. So let us discuss them. So immediately you can write it down with the pencil somewhere in your textbook and mark the answers. The first additional question is define. Definition. So many definitions are there in this lesson which they have not given in the textual exercise, and each and every definition should be known by you very thoroughly. They can be asked for 1 mark as a definition, or means fill up type, or under true and false. So the first is refraction of light. The definition is on page number 73. Mark it carefully. First define is 1a, refraction of light. Page number 73, you can see the definition in bold black font in your textbook. Light changes its direction when going from one transparent medium to another transparent medium. This is called refraction of light. Next definition is dispersion of light. Definition 1b is dispersion of light. Mark the definition on page number 77. Again, the definition is given in the textbook in a unique way in dark, bold, black font. The process of separation of light into its component colors while passing through a medium is called dispersion of light. I hope both the definitions are marked by you. Now let us move to question number 2. State the laws of refraction. Very important question from examination point of view. We are speaking about the board exam point of view. Question is, state the laws of refraction. Mark the answer on page number 74. If this question is asked 100%, you have to draw the diagram. Without the diagram, your answer here will not have that much of meaning. So see, you can see on page number 74, under the heading you have laws of refraction, 2 points. So both the points you have to write. Here I have shortened it in the slide. You have to write the entire point from the textbook. Incident ray and refracted ray at the point of incidence N are on the opposite sides of the normal to the surface of the slab at that point. That is, you will write CD, and the 3 incident ray, refracted ray and normal are in the same plane. Point number 2, continue marking. For a given pair of media, the ratio of sin I to sin R is a constant. Here I is the angle of incidence, R is the angle of refraction. So sin I upon sin R, this you will get in the green colored block on page number 74. See, just below the loss you have the green colored block. There you will get sin I upon sin R is equal to constant, that is equal to N. N is called the refractive index of the second medium with respect to the first medium. This second law is also called Snell's law. They can also ask you state Snell's law. So there you have to elaborate it with the help of second point. I hope all of you have marked question number 2, laws of refraction. Let us move towards the next additional question. It is a short note. Write a short note on twinkling of stars. Now here I have given this answer as a short note. Doesn't mean the same way it will be asked in the board exam. On page number 76, you can see in the textbook, even during the explanation, I had displayed you on the slides the diagrams of apparent position of a star, effect of atmospheric refraction. So that diagrams can be placed ahead of you. You have to identify which phenomena it is and you have to explain it. Or a short note can, a give reason can be asked on this part. Stars appear to be twinkling in the sky. So this give reason also you will give the same answer. Mark carefully on page number 76, point number 1. Question is write a short note on twinkling of stars or give reason for stars appear to be twinkling in the sky. Point number 1, page number 76. You can see above the diagram you have the paragraph about stars. Above diagram 6.6 and 6.7, the paragraph above it starts your first point. Stars are self-luminous and appear to be point sources as they are very far away from us. You have to just shorten up the point which is given in the textbook. Point number 2, second line in the same paragraph, last 2 words. As the density of air increases with lowering height above the surface of the earth, the refractive index also increases. Continue marking. Starlight coming towards us travels from rarer medium to denser medium and constantly bends towards the normal, which makes the star appear higher as compared to its actual position. Point number 2 and 3 as it is given in the textbook you can mark. Point number 1 you have to just change, shorten that point. Continue marking below the diagram. Point number 4, the apparent position of the star keeps changing a bit because of motion of atmospheric air and changing air density and temperature, thus changing the refractive index of air. Last point. Hence, the position and brightness of the star keeps changing continuously, due to which they appear twinkling. That is the second last line of your page number 76 is your 6th point. So only the first point you have to shorten from the textbook. Rest all as it is given, I have given you in marking. I hope up till question number 2 you have no doubt. The next additional question is a give reason. Question number 4, give scientific reason for, very important, planets do not twinkle. Give scientific reason for planets do not twinkle. On page number 77, very first line, or you can say the first paragraph, you will get the answer. Mark carefully. Planets are much closer to us as compared to stars. Hence, they do not appear as point sources, but appear as a collection of point sources. See, on page number 77, the very first line of that page, first line, second line, just you have to change the words. Don't write it as it is given in the textbook. So, the first reasoning here is planets are much closer to us as compared to stars. Hence, they do not appear as point sources but appear as a collection of point sources. So, you can see here different color is used and it is underlined. So, that is the main reasoning part. So, you have to also underline in the exam. Point number 2, because of changes, you can see this point is clearly given in the textbook, third line on page number 77. Because of changes in atmospheric refractive index, the position as well as the brightness of individual point source change, but the average position and total average brightness remains unchanged. Hence, planets do not twinkle. Even this part is given in the textbook. I hope you have marked carefully on page number 77. First point, as I have told you, little bit you have to change. So the main part is planets are closer to us, hence they appear as collection of point sources, and average intensity remains same, hence planets do not twinkle. The next is additional question is a small diagram. Draw a neat labeled diagram of dispersion of light. This diagram is 6.8 from page number 77. As I have told you not to use any colors in the diagram. If you want to express your colors, you can write the full names of the colors. This diagram can also be given as a diagram to you in the exam, and based on this diagram different questions related to dispersion of light can be asked. Who was the first scientist who obtained this spectrum? The answer is Newton. Then when you get a spectrum of 7 colors, which color bends the most, which color bends the least? So red bends the least, violet bends the most. What is a spectrum? The 7 colored, you can say the colors, component colors of a light ray which you get on dispersion of light is a spectrum. Or define what is the phenomena related to and define it. So the phenomena is dispersion of light, and then you can define it. So these are the different types of questions which can be asked. With this we complete with the discussion of additional questions. On page number 78 you have about the partial and total internal reflection, its definitions you are going to study. Now we move on to the activities for this chapter. Here now textbook should be compulsorily there in your hands. Page number 73. First activity, can you recall? Can you recall? Page number 73. The first question is very simple, which you have learned from your lower standards. What is meant by reflection of light? A small definition of reflection of light, whichever you think relevant, whichever is easy for you, you can write. You can refer the lower standard textbooks. I have obtained this definition from the Google Net. You can obtain it from anywhere. When a ray of light approaches a smooth polished surface and the light ray bounces back, it is called reflection of light. Very simple definition you have to write. Second question, purposely, what are the laws of reflection? I have not answered for you. I have told you light from the lower standards you are studying the laws. The incident ray, the reflected ray, the normal, all lie in the same plane. Angle of incidence is equal to angle of reflection. So all these laws you know it. So just go through. It will not be asked in the exam. Our next activity is use your brain power on page number 74. On 73 we have completed. Then even if you see page number 73, there are activity number 1, 2 and 3. 1 and 3 I have already discussed in the explanation about the pencil and the glass slab. So go through them very thoroughly. Page number 74, use your brain power. Very simple. Will light travel through a glass slab with the same velocity as it travels in air? Yes. Will the velocity of light in the glass slab and the air will be same? Surely it will not be same, because light's velocity is different in different medium. So the answer is no. Second question, use your brain power on the same page. Will the velocity of light be the same in all media? Again related to question number 1. Here you know that the velocity of light in different media is different. So velocity of light will not be same in all the media. So answer is no, the velocity of light will not be same in all media. The denser the medium, slower the light travels. Very simple activities. So page number 73, 74 activities are over. 75 if you see, no activities are there. Page number 76, extremely important activities. Can you tell? So refer page number 76. The first one is under can you tell. Have you seen a mirage, which is an illusion of the appearance of water on a hot road or in a desert? Explain. Both these questions, if the reduction in syllabus we don't get, then both these questions are very important from board examination point of view. If the reduction in syllabus is on the way, then both these questions will be moved out as a reduction part. So till then we are just going to see what is a mirage and how it is experienced in the summer season on the hot road or in a desert. So first point is you are going to explain what is a mirage. A mirage is nothing but a small scale effect of atmospheric refraction which is observed on a hot day in the desert or road. So what is the question? That part only we are going to take over here. So in the first point you are going to explain about what is a mirage. For the further marking, you can refer your textbook on the same page, page number 76. Point number B is the air near the hot road or the desert surface is hot and hence rarer than the air above it. The air which is in contact of the hot road or the desert surface is much hotter than the air which is above it. So that should be your second point, page number 76 in your textbook. The very first paragraph, second line, third word. Page number 76, first paragraph, second line, third word, that is your point number 2. The air near the hot road or the desert surface is, and near the holy flames, that part you can cancel off, is hot and hence rarer than the air above it. Point number 3, refractive index of air keeps increasing as we go to increasing heights and the direction of light rays coming from a distance keeps changing due to refraction. Continue marking. You can see there in the textbook the refractive index of air keeps increasing as we go to increasing heights. In the first case, that part you cancel, and the direction of light rays coming from a distance keeps changing according to the laws of refraction. Next point you can continue marking. The light rays coming from a distant object appear to be coming from the image of the object inside the ground. This is called a mirage. Now, if such a type of question is asked in the exam, on page number 76 you can see diagram 6.5 about mirage. In short, immediately you have to draw the diagram. I hope you have got the correct answer. Have you seen a mirage, which is an illusion of the appearance of water on a hot road or in a desert? First point is what is a mirage. Then you know that the air near the desert surface, it is hot, and hot means rarer than the air above it. So again, rarer, denser, two medium are there. So refractive index keeps on increasing as we go to increasing heights, and the direction of light rays coming from a distance keep changing due to the refraction, and then it is a mirage. Next question, same page, under the heading, can you tell? Have you seen that objects beyond and above a holy fire appear to be shaking? Why does this happen? Actually, do they shake? No, they appear to be shaking. So point number 1 over here is yes. They have asked us, have you seen? So your answer is yes. Objects beyond and above a holy fire appear to be shaking. That should be your first point. After you say yes, they have asked, why does this happen? Again, as you have mentioned, point number 2 in mirage, here also same thing. The air near the holy fire is hotter and hence rarer than the air above it. Only in the previous question we had mentioned air near the hot road or the desert surface. Here you will write air near the holy fire. Point is same, concept is same. C is the direction of light rays coming from objects beyond and above the holy fire changes due to changing refractive index above the fire. This point you will get on page number 76, third paragraph of that page. Paragraph number 3, where you have marked just now for mirage, the consecutive paragraph after that. In the beginning they have given in the second example. Cut that part and start writing as their third point. The direction of light rays coming from the objects beyond and above the holy fire, they change due to the changing refractive index above the fire. Thus, the objects beyond and above a holy fire appear to be shaking. This appear word is very important. Actually, they do not shake, but due to the continuous changes in this refractive index, the rarer medium, the denser medium, they appear to be shaking. With this, we complete the two important activities on page number 76. Now, page number 77, you have one activity, use your brain power. From incident white light, how will you obtain white emergent light? By making use of two prisms. Here, first thing you have to take one prism. So your first point should be take a glass prism and allow the light ray to pass through it. Then place another identical prism. This identical word is extremely important, in an inverted position with respect to the first prism. The question asked to us is, from incident white light. Incident means the light which is passing through one of the prisms. How will you obtain white emergent light? By making use of two prisms. So your first point here should be take a setup. So for a setup, take a glass prism and through that glass prism allow the light ray to pass, means let the white ray be incident on it. Then place another identical prism, but the position should be upside down, inverted position with respect to the first prism. Now here one care you have to take is allow the colors of the spectrum, the 7 colors of the spectrum, to pass through the second prism. You know, when light will pass through the first prism, what will happen? You will get a spectrum of 7 colors. So that spectrum you should allow to pass through the second prism, which is placed in a inverted way, and you will obtain a beam of white light emerging from the other side of the second prism. They have asked, how will you obtain white emergent light? So when a white ray of light is allowed to pass through one glass prism, the spectrum which you get, you allow it to pass through the other identical prism which is placed in an inverted position, and on the other side you will get white emergent light. I hope you have understood. Now here you can see the picture of a chandelier, means in Marathi you call it as zumbar. You can see different lights, yellowish shade in big hotels, 5 stars and all when you go. Even in your houses, the big houses and all, you have such chandeliers in your house. So on that you have a very small activity. They have asked us on page number 77, same heading, use your brain power. You must have seen chandeliers having glass prisms. The light from a tungsten bulb gets dispersed while passing through these prisms and we see colored spectrum. If we use an LED light instead of a tungsten bulb, so in place of a tungsten bulb, if you make use of an LED light, will we able to see the same effect? Answer is yes. Yes, with the help of LED bulb also, you will be able to get the same effect. And that is why I had placed the picture of a chandelier, that is a zumbar in Marathi. On page number 78, if you see in the textbook, you do not have any activity. So for this chapter, we have completed the explanation. We have completed with the textual exercise, activities and additional questions. So in our next session, we are going to solve the numerical examples. The solved examples which are there on page number 79, the textual numericals, 2 textual numericals are there, and one question, that is question number 2a, proof, which is remaining, that we will complete in our next session. And along with that we are going to start with a new chapter, that is chapter number 3, chemical reactions and equations. So I request all of you, when you attend the next session, at least 4 to 5 pages of chapter number 3, you just go through. It is a chapter from chemistry, a very easy and simple chapter, but you have a number of chemical equations in that. So your memory part of the brain should be very strong. Read the 4 to 5 pages of the chapter before you attend our next session. Also sit with textbook, pencil, because we are going to solve the numericals and the proof in our next online session. So till then, I request all of you, see to it that your books are completed, see to it that your study is in progress, reading, completion of the journals, everything is going on time. Thank you, dear children.